So we want to look at another example of solving a polynomial equation that won't factor. Here we want to find the zeros of f of x equals x cubed plus 7x squared plus 11x minus 3. Well, the first thing we want to do is set that equal to 0. And if we look at that, it's obvious that it won't factor. It has 4 terms, and the only possible way to factor it would be by grouping. But in this case, none of our terms have any common factors, so that's not going to work out. That's going to leave us with the rational root theorem. So let's make a list of possible rational roots. Possible rational roots. Remember that to do that, we have to consider both the positive and negative factors of the constant, so -3, so that would be positive and negative 1 and 3, divided by the leading coefficient. Well, we get really lucky here because the leading coefficient is a 1, and the only factor of 1 is 1. So that means that we have positive and negative 1 and 3 that we have to test. So I need to figure out which one of those to perform synthetic division on. Now remember, we could just start trying synthetic division until we get to one that produces a remainder of 0. But we're going to cheat a little bit and take a shortcut and go to our calculator and type in our polynomial and use our calculator to help us find that first 0. So let's go to y equals and clear out what we had in there and type in the new problem. X to the third. Ooh, we need to be sure we come down out of that exponent. So x to the third plus 7x squared plus 11x minus 3. So that's my new polynomial, and that's what I would like to solve equal to 0. So let's go to our table and delete what's there, and let's check our new possible rational roots. So we've said there are only 4 of them. Positive 1, negative 1, positive 3, negative 3. Positive 1 doesn't work. We need a 0. We need the remainder to be 0 and the y value to be 0 in order for that to be a solution. So let's try negative 1. Negative 1 doesn't work as well. I like to try 1 and negative 1 first, just because it's easier for me to multiply through by 1. Multiply with 1s than any other number. So I like to try those first. But since those are out, let's try positive 3. Ooh, positive 3 doesn't work either. And so that's our last possibility. If this one doesn't work, that means this thing has no rational roots. It's our last hope. Negative 3. And negative 3 does produce a remainder of 0. So that means I would like to synthetically divide by x plus 3 and let my synthetic divisor be negative 3, because negative 3 is one of my roots. So we have negative 3, and then list our coefficients, 1, 7, 11, and negative 3. And we can see from the result of synthetic division that we get 1x squared plus 4x minus 1 with a remainder of 0. So that's really what we want. We want to rewrite this in factored form now and kind of see where we stand. So this right here, this synthetic divisor, because it's a solution, we know that it produces the factor x minus negative 3 or x plus 3. Now this piece, my quotient, produces the quadratic 1x squared plus 4x minus 1. And I know that's a quadratic because I know that my original was at x cubed, and once I perform synthetic division once on it, I come down to the second power. You drop a power each time you perform synthetic division. So, I know the first answer. I know the first answer is negative 3. I knew that just from the table on my calculator and from my synthetic division. I want to know the other 2 possibilities. I have x squared plus 4x minus 1 equals 0. That's a quadratic, so it's ready to be solved. But unfortunately, this time, it cannot be solved by factoring. We're going to have to solve it using the quadratic formula. So I can solve this one right off the bat. There's one answer. But this one, I'm going to need to work on a little bit more. So I'm going to go off to my other side here, and I'm going to perform the quadratic formula on that one. So x equals opposite b plus or minus the square root of b squared, positive 4 squared is 16, minus 4 times a times c, all over 2 times a, which in this case is 2 times 1. So now we have negative 4 plus or minus the square root of positive 20, all divided by 2, which gives us negative 4 plus or minus 2 square roots of 5, all divided by 2. And finally, that will simplify to negative 2 plus or minus the square root of 5. So there are my other two solutions. So for my final answer, my solutions are negative 3, negative 2 plus the square root of 5, and negative 2 minus the square root of 5. So in this case, we had only one rational root, and our other two roots turned out to be irrational. We got them from the quadratic formula. For our final example, we would like to find the solution set for the polynomial p of x equals x to the fourth minus 6x squared minus 8x plus 24. So the first thing we're going to do, set it equal to 0, and generate a list of all of the possible rational roots. So in this case, using the rational root theorem, it looks like we could have plus or minus 1, 2, 3, 4, 6, 8, 12, or 24, all divided by, we're getting really lucky here, just plus or minus 1. Only factor of our leading coefficient is a 1. So that basically means I just need to check all of those top numbers and the bottom numbers until I come to one that works. So I'm going to go to our calculator. Just for the sake of time, clear that out. We're going to type in our new problem. X to the fourth minus 6x squared minus 8x plus 24. So there's the polynomial we'd like to solve. We're going to go to the table, and delete the ones that are already there. We're going to start over. We're going to start looking to find one of our rational roots. So if I try positive 1, I do not get a 0. If I try negative 1, I don't get a 0 either. How about positive 2? There we go. There's our first rational root. Positive 2 returns a value of 0, which means that x minus 2 is a factor of this polynomial. So we are going to perform synthetic division on positive 2 to factor this problem down from a 4th degree to a 3rd degree. Let's make positive 2 our synthetic divisor. We have to be really careful here. I have a 1, and then that's my x to the 4th coefficient, but my x to the 3rd is missing. So we have to put a 0 to hold its place. Minus 6x squared minus 8x and positive 24. So let's make sure we got all of our places. The 4th, 3rd, 2nd, 1st, and 0 power for the constant. So there's synthetic division on our first one. And we can use that to produce the factored form x minus 2 multiplied by 1x cubed plus 2x squared minus 2x minus 12 is equal to 0. Now, unfortunately, we are still not down to the 2nd power. So I'm going to have to start this process over again. I need to go back to my calculator, and I now need to try to solve this new polynomial. I need to find a solution to the new polynomial so that I can hope to factor it down one more time into quadratic form. Now, you don't have to generate a new list of possible rational roots. You can just use the old ones. So let's go back and let's change what's in our table, and let's now try synthetic division on the cubic, and let's see if we can find a root for it. Okay, so let's go to y equals, and let's change our polynomial to x to the third plus 2x squared minus 2x minus 12. So we're going to go over to our table, and we are going to check our possible rational roots. 1, -1, 2, -2, 3, -3, 4, -4, and so on, until we find one that produces a 0 value for this new polynomial, this third degree. So let's see if 1 works. No. -1 doesn't work either. But look at this. +2 works, which means I can use synthetic division again on +2. That means that +2 must be a double root for this particular polynomial, which is kind of interesting. So let's try to do synthetic division again on +2. Now, if +2 didn't work, we would try -2, 3, or -3 until we found another one that would work. So we're going to do synthetic division again on +2. So we have 1, 2, -2, and -12 as our coefficients. Bring down the 1. 2 times 1 is 2. 4 times 2 is 8. And 6 times 2 is +12. So that brings us up to the first factor we found was x minus 2. That came from this synthetic division process. Then, on the next one, we found that 2 worked again, which means that I can continue factoring that cubic into x minus 2 again. And that leaves us with this result. And now that will be quadratic. That will be 1x squared plus 4x plus 6. And thankfully, once we drop to quadratic, we don't have to use synthetic division anymore. We can utilize either factoring, quadratic formula, completing the square, or the square root property to solve this, to continue solving. So we know the first two. The first two solved equal to 0 produce twos. The problem is what's going to happen to the quadratic, because it turns out it won't factor. So we're going to have to do the quadratic formula on it. We should be getting very good at this by now. So we will say x equals opposite b plus or minus square root of b squared, which is 16, minus 4 times a times c, which in our case is +6, all over 2a, which is 2 times 1. So we have -4 plus or minus the square root of 16 minus 24, which is -8, all over 2. And these are going to be imaginary roots. So we have -4 plus or minus 2i squared of 2 all over 2. And those simplify into -2 plus or minus I square roots of 2. So let's talk about what our final solution set is, and that will wrap up section 5.3. Now 2 is a double root and it had a multiplicity of 2, but we do not have to list it twice for our final answers. We only list it once. So 2, and then we have -2 plus I squared root of 2, and -2 minus I squared root of 2. So it looks like this problem only has 3 solutions, but it's really because the +2 is acting as a solution twice.